So we will do one example, but it has several parts to it. And I've given you the position function in your instructions here that S of t is equal to negative 16t to the second plus v sub 0 t plus s sub 0. And I did want to make sure you know the vocabulary of v with a subscript of 0 stands for the initial velocity. And sometimes you have to interpret that from the information that's given to you. So this problem is about a silver dollar dropped from the top of a building. So something that is dropped starts off with an initial velocity of 0. And since the building, later on you'll read, is measured in feet, I did not give you in these instructions a unit for your velocity, but we will use feet per, and then since it's measuring an object falling, it would make sense that the time unit would be in seconds. So this will be 0 feet per second. Because this object was dropped, it's starting off with an initial velocity of 0. And then we'll look at the S of t also, or excuse me, in the S of t, there's also an S of 0. That stands for initial position. So where was this object when the time count began? And that would be at the top of the building, which was 1,362 feet. So you have the initial position. And so that makes our answer to part A, S of t equaling negative 16 t to the second. And then since your initial velocity was 0, taking 0 times time is just going to be 0. So there won't be a t term in this problem, and then plus the S0, which is the initial position. So our position function is S of t equals negative 16t to the second plus 1,362. And then the velocity function is, remember from the front, the velocity function, v of t, is nothing more than the derivative of the position function. So it's s prime of t. And so v of t, try to separate that a little bit more. V of t for this problem, taking the derivative of negative 16t squared, we'll multiply the 2 by the negative 16. That's negative 32t. You reduce your exponent by 1, and that makes it t to the first. And then the derivative of the constant is 0. So our velocity function is negative 32t. Now, one thing about doing the calculus, you do have a tendency to lose the meaning of the units. So you're going to need to know that velocity for this problem is measured in feet per second, and the position is measured in feet. So as we move along, that we've finished part A. Part B is asking for the average velocity. So the average velocity on a time interval from 1 to 2. So I want you to understand that the 1 is a beginning time, the 2 is an ending time. So maybe it would be helpful to set this up as ordered pairs, which means we would need to know the position at time 1. So S of 1. So if I'm going to plug 1 in for the t, then I would get 1,346. Now, I can go ahead and show this. I don't have a lot of room, but I think I can squeeze this in. So I'm just plugging in 1, and so S of 1 is going to equal, as I said, 1,346. I can also find S of 2, and so S of 2 means I'm going to plug in the 2 into the position function. And S of 2 equals 1,298. So my average velocity on the interval from 1 to 2, V average, is going to equal S of 2, which is 1,298, minus S of 1, 1,346, over, and then 2 minus 1. And so doing that calculation, you get your average velocity as a negative, so equals negative 48, and then 1 in the denominator. And then let's think about the units. So the units of the numerator, those are positions. Those are measured in feet. And if you think about the units in the denominator, those are times. And so it's negative 48 feet per second. And here's where you get the idea of a negative for the velocity. Since the object was dropped, then it's going down, and that negative is an indication of that direction. And then the 48 is an indication of the speed. So negative 48 feet per second would be the average velocity. And notice that we had to have an interval of time from 1 second to 2 seconds. But for your next question, part C, you're asked to find instantaneous velocities. So we want to know in this question, what's the velocity of this dropped object at 1 second? So at a time of 1 second. Well, that just means that we need to do V of 1. And we calculated V of t right here. That was just your derivative of your position function. So V of 1 would be negative 32 times 1. And so V of 1 is negative 32. And this is where I wanted to remind you, doing the derivative work, you do have a tendency to lose sight of your units. So you're going to have to remember that velocity for this problem is feet per second. So this would be negative 32 feet per second. Again, negative because the object is falling. Then I also am asking you in part C for the instantaneous velocity at time equals 2. So we'll do V of 2. You plug in 2 for the t value, and you get negative 64. And again, that is in feet per second. So we know the velocity not just over an interval of time, but at certain instances in time. Part D is asking you the time required for the coin to hit the ground. Now, this actually gets back to just a little bit more algebra. For something to hit the ground, then its position would have to be 0. So that means that we would need to set the position function S of t equal to 0 and find out when. So we're going to solve for time. When did the object hit the ground? So S of t, I think I'll do that work over in here. Negative 16t to the second plus 1,362 equals 0. You have many tools at your disposal to solve this type of problem. You could do the quadratic formula. I think it looks pretty natural to get the t squared by itself. We could subtract the 1,362 and then divide by the negative 16. That's going to get us at t squared equals whatever that fraction is, 1,362 over 16. And then to get t, you could do the square root of that. So square root both sides. We only need the positive root, and we'll approximate that. I'm going to have you go to 3 decimal places. And so t is 9.226 seconds. If you do that on a calculator, you might want to store it or keep that value because we're going to need it in the next little section. So 9.22 seconds. And then finally, part E, which I had to squeeze in to make it fit on my video screen. So part D is what I've written right in here. This is all part D. Part E, the velocity of the coin at impact. Well, so I'm wanting the velocity at a certain moment in time. The moment in time that I want that velocity for is when it hit the ground, which is my answer to part D. So I want to know what's the velocity at the 9.226 seconds. So in other words, I want to do V of 9.226. And that's why I said you might want to store that. It's better to use a stored value than to use a decimal approximation. But that means I'm going to substitute in the 9.226 into my velocity function, negative 32t. I'm not going to show that substitution this time. That's going to give you negative 295.242 feet per second. So that object is moving at that point. So negative 295.242 feet per second. So with this one example, I tried to show you a good variety of the types of things that you could be asked. Things like when something hits the ground, you would set your position equal to 0. When or what is instantaneous velocity? So you have to do the derivative. Average velocity, where you need 2 ordered pairs in order to calculate slope. So you'll have a variety of application problems as you work on this assignment. Be sure to ask questions when you need help, and good luck.